Guys, today we're doing inverse. Inverses! Oh boy. So, first of all, we remember f of x is how we write a function, whatever function we want. We can have a line, mx plus b, or we can have a quadratic equation, doesn't matter. Whenever we talk about an inverse, we use this little symbol right here. -1 looks like the f to the -1 power, looks like an exponent, but it's not. This is how we say inverse in math. Instead of writing this word here, we write this little symbol, f -1. So, what does it mean? How do we know if something has an inverse or not? That's the deal. So, it's called one-to-one. The function has to be one-to-one, and so we need to talk about what does that even mean. Well, for it to be a function in the first place, if you remember, the definition of a function is that there's one there's one y value for each x value. Right? So that means that, let's draw a couple of pictures here, that something like this is a function because every x value has one y value. This x value has one y value. This x value has one y value. Even like this is a function because this x value has one y value, and this one has one, and this one has one, and this one has one. And this guy right here is not a function because this x value has two y values, right? The same x, this x has a y value up here, and it has a y value down here, right? So the same x has two y values. That's not allowed. So this is not a function, right? So we know that the vertical line test tells us whether something is a function or not. So this is a function because when I draw a vertical line, it crosses only once. This is a function because when I draw a vertical line, it crosses only once. This is not a function because when I draw a vertical line, it crosses twice, right? So what does this do? The horizontal line test makes sure that something is one-to-one. It has to pass both. You have to pass both these tests. Both of these tests has to be passed. So what does the horizontal line test tell you? Well, if the vertical one says there's one y value for each x, the horizontal line test is going to tell you that there's one x value for each y. All right? So this one right here, if I draw the horizontal line test here, it crosses one time. No matter where I draw it, it only crosses this graph one time. But on this parabola, it crosses twice. This guy is one-to-one. This guy is not one-to-one. All right? This guy is not, because there's two x values for one y value. If I pick the y value 4, well, I can find an x value over here and another x value over here on positive and negative, you know. This one obviously is not one-to-one. It's not vertical or horizontal. It doesn't pass either of the tests, right? So, for something to be one-to-one, that means it has to pass both these tests, the vertical and the horizontal line test. That means there's one x value for each y, and there's one y value for each x. That's very important. So if it is one-to-one, if it passes these two tests, then what we have is something that we can make an inverse out of. Right? So to speak to this, even problems, you know, parabolas or x to the 4th graphs, w's, right? Or x to the 6th graphs, like that, you know. These guys do not ever have an inverse, right? The whole graph. Now, you can restrict the domain. You can cut this graph in half, and then, yes, I have an inverse for that piece of it, right? As long as if I cut it in half, then the horizontal line will only cross it once, and a vertical line will only cross it once. So this will be 1 to 1 if I cut my parabola in half. Same thing is true here. I can cut it on any one of these things. You know, I can take it right here. That part would have an inverse, right? Right? So you can split it up in any little piece that you want. Doesn't really matter. You can restrict the domain and make it work. So even degree, so this was x squared, the whole graph. This is x to the 4th, x to the 6th. Any even degree does not have inverse unless you restrict the domain. If you cut the graph in half, then you can get an inverse. And odd degrees, like y equals x, or mx plus b, let's try mx plus b, that's a line, or y equals something x cubed plus something plus something plus something plus something, right? Or x to the 5th. These guys have, a straight line would have an inverse because a vertical line touches it once, a horizontal line touches it once. The cubic equation that looks like this would definitely have an inverse. The horizontal line touches it once, the vertical line touches it once. The guys that look like this do not have inverses, remember. So odd degrees sometimes have an inverse, sometimes don't. It depends on if the horizontal line crosses it in more than one spot. So this one cannot have an inverse because the horizontal line crosses it more than once. So that's the vertical and horizontal test. That's talking about even and odd degrees. What is this y equals x business? Well, the cool thing, so do I have a color? I do have a color. Yay! Do I have two colors? That's the question. I think I might have two colors. There we go. So, if I have a normal everyday line, doesn't matter where it is, let's draw my line. So this is my original function. Now then, the inverse, what happens is you reflect it across this line right here. You reflect it. So what does that mean? What does that mean? So here is what that means. If I know the values of these numbers, let's just say we know that this is 0, 2, excuse me. Excuse me, again. And this is 1, 2, 3. This is 3, 3. And let's say this one is 1, 2, 3, 4, 5, 6. So this one's 6, 0. Okay? So let's say we know these three dots on the graph. On this blue line, I've got the x-intercept at 6, 0. I've got the y-intercept at 0, 2. And I've got one of the other dots on the line. Right? Now then, what happens whenever I want to find the inverse? Well, if I know this, if I know 6, oops, wrong color. So here's my original. So if I know that 6, 0 and 0, 2 and 3, 3 are all on my original graph. So 6 is the x and y. The domain is the x numbers and the range is the y numbers. Now, to find the inverse, I don't even have to know the formula of this line, although we will learn how to do that tomorrow. I don't have to know the formula. I already know what the points are, because if 6, 0 is on the graph, then 0, whoops, let's do it a different color. Then 0, 6 is on the inverse. What am I doing? I'm switching the x's and y's. So here, 2, 0, I switch the x's and y's. It's like I'm taking it and flipping it over. Here it doesn't matter because 3, 3 stays the same, right? So what does that mean? That means that my graph, whoops, this is negative 6. Isn't that silly? Look, did you see that? That's negative 6. Negative 6. That means this one's negative 6 as well. Okay, now we're cooking with gas. Okay, so 1, 2, 3, 4, 5, 6. There's 2, there's 3. Alright, so if I was drawing this picture, the inverse graph, this is the inverse graph, I'd have to cross right here, and then I'd have to cross right here, 2, 0, so my line is going from 6 to 2, and then from 2 to 3, and then from there on up. This guy right here is a reflection over this line, y equals x. So what we do is we reflect it. Now what that means is if you had a piece of paper, you could fold it on this line, right? If you fold it on this diagonal line, then whenever you unfold it, if you write with pencil, when you unfold it, you'll see where the other line could be. I'll show you that. It's kind of cool. So finding the inverse is as easy as just flipping the numbers around, discovering what goes where. So if I wanted to know, let's do one with a parabola. You say, wait a minute, I thought you couldn't do a parabola. You're right. But we can change restrict the domain. So let's say we have a parabola that looks like this, right? It stops, let's say this is 0, 1, right there. And then this could be 1, 1. And then up here, let's say that would be 2, 3, 1, 2, 3, there we go, 2, 3, right? And so if I know this, remember I cannot find the inverse of a parabola. But if I restrict the domain, if I cut it in half, if I say I'm only going to look at the right side of this parabola, well, now I can find an inverse. Yes, I can. So this is my original parabola, right? Only half a parabola. This is the original. So the x is 0, 1, 0, negative 1. What is wrong with me? And then, and then the x-intercept is 1, 0, and then 2, 3. That's my points, right? So, how do I find the inverse? Well, heck, I know what to do. Yeah, all I have to do is reflect it over this line, right? If I reflect it, everything over here is going to move up here, right? Everything down here is going to move up here. And so if I reflect it, well, let me show you what it would look like. Well, let's just find the points. Negative 1, 0, 0, 1, and 3, 2. So negative 1, 0 would be right here. 0, 1 would be right there. And then this is 1, 2, 3 would be right there. 2. Okay. Ta-da. All right. So what do we have? We have a graph that goes from here to here, and then goes up here like this, woo, and then goes like this forever and ever and ever. This is the graph of a square root function, right? This is the graph of an x squared plus something function, right? Plus blah, blah, blah. This is a square root of x, blah, 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 function, right? Plus something, minus something, whatever. So we know that what's happening here is we're just switching x's and y's. So what we say is that the domain of the original, domain of f of x equals, what does it equal? It equals the range of this. See, 0, 1, 2, 0, 1, 2, the range of the inverse. So domain of f equals the range of the inverse. That's what. Remember, that's how you write inverse. You say x -1. Right? I lost my my computer turned off. I hope it's still working. Let's see. Dadgummit. Well, still working. Yay. Okay. I didn't recognize it was not working. There we go. So, the domain of this is equal to the range of that. And then that means the opposite is true as well. The range of the original is equal to the domain of the inverse. So, this is true going both ways. The domain equals the range, and the range of this guy equals the domain of the inverse. Absolutely true. So what's the definition? That's the last thing we need to know. And then we're done. Hallelujah. The definition says, if you have two functions, and this happens, then they're inverses of each other. So what am I saying? That means if I hook them together and they solve out to be the same exact thing, when I put a number in here, I get that same number out. If I put a number in here, I get the same number out. Let's put it this way. Let's look at it this way. If f circle g equals x and g circle f equals x, then that means these guys equal each other and they are inverses of each other. So that means g is f inverse. Right? If this works and this works, then g is f inverse. We know it's the inverse. So this is what the definition is. Now all this is on the reading from page 372 all the way to page 379. So from 372 all the way to 379, everything I just showed you, everything I just talked about is in the reading. And the first homework we're doing is all about the reading. So I recommend you read it again and then do the homework. That's it. Bye.